First, obtain 3 beakers, one 150 milliliter sized, label this beaker 1, a second beaker 250 milliliter sized, label this beaker 2, and a third beaker at least 450 milliliter sized, though larger is fine as well. Label this largest beaker, beaker number 3. You're also going to obtain a small stir bar. In your lab notebook, you will record the mass of each of these 3 beakers as well as the mass of the stir bar. Make sure that you clearly label your data in your lab notebook so that you know the mass of each beaker. You should label your data mass of beaker 1, mass of beaker 2, mass of beaker 3, and mass of stir bar. Remember to record all digits that are displayed on the scale when you're measuring mass. All of these digits are significant. Now you're ready to obtain your unknown solid. Record the number of your unknown in your lab notebook. This unknown is a mixture of sodium chloride, calcium carbonate, and silicon dioxide in various quantities. Your task is to separate each of the components of this mixture and to then determine the mass percent composition of each in the original sample. After you've recorded your unknown number, transfer the entire contents of your vial to beaker number 1. Then record the mass of beaker number 1 and your unknown sample. In your lab notebook, make sure that you're recording your data clearly. This is the mass of beaker number 1 and your unknown mixture. Back at your lab bench, obtain a 50 milliliter graduated cylinder and a bottle of deionized water. Measure out 50 milliliters of deionized water. You can remove the lid of the DI water bottle to pour more quickly, but once you get close to the volume that you want, reattach the lid and add the final few milliliters using the spout so that you can get a precise volume. Transfer the 50 milliliters of DI water to beaker number 1 containing your unknown mixture. As the water is added, think about what is happening to each of the 3 substances in your mixture. Think about why we're adding DI water and how that's going to help us with separating the components of the mixture. Place your stir bar into this beaker as well, and then you're going to transfer the beaker to a stir plate. A stir plate is a convenient piece of laboratory equipment that allows us to stir mixtures using a magnetic stir bar. Place your beaker near the center of your stir plate and then slowly turn the knob to activate the stir. As you do this, you may need to recenter the beaker. The stirring works best when the beaker is right in the center so that the magnet is lining up with what's in the stir plate. Gradually increase the stirring speed to a fairly rapid stir. You're going to stir this mixture for 2 minutes. While your mixture is stirring, we can prepare for the next step, which is a gravity filtration. For this, you'll need a long stem filter, a large piece of filter paper, your beaker number 3, a ring stand and ring, a rubber policeman, and a glass rod. First, attach the ring to the ring stand by sliding it over the top and tightening the clamp. Lower the stem until you're about 2 or 3 inches above beaker number 3. Place the funnel into the ring and adjust it so that it lines up with the edge of beaker number 3. Now, obtain a large piece of filter paper. Fold this in half, and then fold it in half in the opposite direction. This gives you a center point on the funnel. We need to make this funnel into a cone shape. To do this, you're going to tuck in one of the quadrants and fold it back so that it gets lined up until you have a nice cone shape. This is a little tricky, so you may need to play with your filter a little bit. Once your filter paper has a nice cone shape, you can place the filter paper into the funnel. You may again need to make some small adjustments so that this lines up nicely with your funnel. We're going to get the filter paper a little bit wet so that it sits a little bit better in the funnel. This also helps the filtration process. Use a bottle of DI water, hold the funnel over your beaker, and add just a small amount of DI water from the squirt bottle so that your filter paper sits a little better in the funnel. There are a lot of steps to setting up a gravity filtration, so you may find it helpful to sketch this setup in your lab notebook so that you know how to set it up when you are in lab. At this point, your 2 minutes of stirring should be complete, so you can remove your beaker from the stir plate. Set this mixture on the counter to let it settle for a few minutes. Our next step is going to be to decant our solution into our gravity filtration setup. Again, you want to have waited a couple of minutes for your solution to settle so that when you're doing this decanting, you're pouring mostly solution and not a lot of solid particles down the glass rod. This helps your filtration go a little bit faster. The decanting process involves slowly pouring your solution down a glass rod while deliberately leaving behind the solid at the bottom of your beaker. Do this slowly and carefully, and make sure you don't overflow your funnel. During this process, you can again think about what is going on in this mixture. What substances are present in the solution, and what substances are left behind as solids. Understanding each of these steps will help you with writing your lab report and with really just comprehending what it is that we're doing with each of these steps in the chemical procedure. Once you've completed decanting the solution from your beaker, you can rinse off any solid left behind on your stirring rod, and then we're going to use a rubber policeman to transfer the remaining solid into the filter. You have a stir bar present in your beaker still, so just scoot that over to the side while you scrape the solid into your filter funnel using the rubber policeman. Once you've scraped out the majority of the solid with your rubber policeman, rinse any residual solid off of the rubber policeman using a small amount of DI water, and then we're going to thoroughly rinse the beaker with DI water. You want to use just a small amount because any water that we add here we need to boil off later. The more water we add, the longer that will take. Once your stir bar is mostly clean of solid, you can pour it out and catch it with your fingers. Make sure you're wearing gloves at this point. Rinse any residual solid off of the stir bar and set it aside. Continue to rinse your beaker until there's no visible solid remaining. Again, do this using as little water as possible because any water that we add here needs to be boiled off in the next step. Once you're satisfied that your beaker is clean, you can set aside beaker number 1. At this point, you'll need to wait for your gravity filtration to finish. Wait until the solid is completely dry and all water has dripped out of the funnel and into beaker number 3. Once your filtration stops dripping and you're satisfied that your solid is dry, you can remove the funnel from your gravity filtration setup. Grab beaker number 3 and place your stir bar in the beaker. You're going to place this beaker along with the stir bar and the solution onto a stir hot plate. Again, center your beaker and slowly turn on the stir until you have a good speed. You're also going to turn on the heat here. Our goal is to boil off all of the water in this solution, which will then leave behind the solid. Set the temperature of your hot plate to 200 degrees Celsius and let this reaction heat and stir until all water is boiled off. This can take up to an hour, so in the meantime, we're going to complete the rest of the experiment. Let's return to the solid left in our filter funnel. We're going to transfer all of this solid into beaker number 2. You can use a rubber policeman to do this. Using your rubber policeman, gently scrape the solid into beaker number 2. Do this carefully, making sure that you transfer all of the solid into the beaker and don't spill any on the countertop. Once you've transferred most of the solid into your beaker, rinse any residual solid off of the rubber policeman using a very small amount of deionized water. We don't want to add too much deionized water here, so really be conservative with the amounts that you're using. You're again going to use a small amount of DI water to rinse out any residual solid from your filter paper. Use small amounts and tiny squirts to transfer all of the solid from your filter paper into beaker number 2. Once you're satisfied that your filter paper is clean of solid, you can set that aside. Now, obtain a small 10 milliliter graduated cylinder and a small beaker that you're going to label HCl. This should not be beaker 1, 2, or 3. This is a separate beaker that you're going to label HCl. Bring your small beaker to the fume hood and carefully pour in a small amount of hydrochloric acid. 6 molar hydrochloric acid is very dangerous. It can cause burns to your skin and blindness if it gets in your eyes. We will not remove this chemical from the hood. Transfer a small amount into your beaker and return that to your lab bench for use. Back at your lab bench, you'll carefully transfer your hydrochloric acid from your small beaker into your graduated cylinder to measure out a volume of 8 milliliters. Pour slowly and carefully, and then use a dropper to fill the remaining volume until you're exactly at 8 milliliters. Remember to get down at eye level with your graduated cylinder so that you can clearly see the meniscus at the 8 milliliter mark. Once you've measured 8 milliliters, set aside your hydrochloric acid beaker and dropper. We will dispose of any excess in the chemical waste container. Slowly transfer your hydrochloric acid into the beaker number 2 containing your residual solid and a small amount of water. Record your observations as this happens. Gently swirl your mixture until all bubbles have stopped. This may take a minute, so be patient. Again, you want to think about why it is that we're adding hydrochloric acid and what it's doing in this mixture of solids. What is it reacting with? What is it forming? And how does that help us in this situation where we're trying to separate these components of the mixture? Once you're satisfied that the reaction has completed, set the beaker on the countertop and allow any of the solid particles to settle. Once your solution has settled for a few minutes, we're going to decant the liquid away from the residual solid left behind. Here, again, think about what it is that we're decanting and what solid is left behind. We're going to decant into beaker number 1. Slowly decant the liquid through the mouth of the beaker down the glass stirring rod. Do this slowly and carefully, making sure that you're not accidentally pouring solid into beaker number 1. Beaker number 1 should contain only the decanted solution. It's okay to leave a little bit of liquid behind in your beaker with the solid. That's better than accidentally pouring a bunch of solid into beaker number 1. To make our separation more complete, we're going to wash the residual solid with small aliquots of deionized water. Measure out approximately 5 milliliters of deionized water and add this to your solid. Swirl this to stir, and then let it settle on the counter until the solid particles have settled back to the bottom of your beaker. Once that's happened, we'll decant again. This is the process of washing a solid to remove any residual dissolved particles while leaving behind a more pure solid. We're going to do this wash 3 times. Again, measure out 5 milliliters of deionized water, transfer it to your beaker with solid, swirl, Then place the mixture on your countertop to let it settle. And now decant again. We're going to repeat this process a third time. The washing process helps to give us a more complete separation of the components of our mixture. Again, here you want to think about what substance is it that's being left behind as a solid, and what is it that we are decanting into beaker number 1. It helps us to be able to understand what it is that's happening at each step and how it is that each step in the procedure is helping us to separate the components of our mixture. After your third wash, you can rinse the glass rod with a small amount of DI water. It's okay if your solid in beaker number 2 still looks a little wet. Because we've done this washing procedure, any residual liquid left in the beaker is just water. We're going to remove this water from the solid using evaporation. Bring your beaker over to the oven, open the oven carefully, and place your beaker in the oven. Make sure that you know which one is yours. You want to have a clear label on your beaker so you can come back and get it later. Carefully close the oven, and you'll wait at least 10 minutes for your solid to dry. After 10 minutes, you can remove your beaker from the oven. Use an insulated glove to remove your beaker as it will be hot. Carefully place your beaker on the countertop and wait for it to cool until you can touch it with your hands comfortably. Make sure you close the oven after you remove your sample. Once your sample has cooled, we need to record the mass. Place the beaker with the solid on your scale. Make sure that you clearly label this mass in your lab notebook. What is the solid? And make sure that you record that it's in beaker number 2. This will be essential for your calculations to be correct later. Back at your lab bench, grab your decanted solution that's in beaker number 1 and place it on your hot plate for about 10 minutes. You want to give it time to heat up and then be boiling for about 5 minutes. You'll be able to tell it's boiling once you see condensation and steam forming on the side, like you can see here in beaker number 3. While your solution in beaker number 1 is heating up, grab a small graduated cylinder and 1 molar sodium carbonate. We're going to measure 15 milliliters of the 1 molar sodium carbonate into a graduated cylinder. After you've measured out what you need, return the cap to the stock bottle and return the stock bottle to the hood. Once your solution in beaker number 1 has had a chance to heat and boil for 5 minutes, you can remove it from your hot plate. Make sure you use an insulated glove to do this, as the glass will be hot. Carefully remove it from the hot plate using an insulated glove and set it directly on the countertop for the next step. Immediately after removing the beaker from the hot plate, slowly add your sodium carbonate to the solution. Do this very slowly. As you can see, this is going to cause a reaction. Record your observations as you slowly add your sodium carbonate. After you've added all 15 milliliters of the sodium carbonate, you may start to see a solid precipitate form in your reaction mixture. As this cools and stirs, we're going to see more and more of this solid precipitate form. To give the reaction time to complete and to fully form the precipitate, we're going to allow the reaction to cool to room temperature as we stir it for 5 minutes. You want to put this on a stir plate that is not heating. We have separate stir-only plates that you can use for this purpose. Stir this mixture gently for 5 minutes as you allow it to cool to room temperature. Be careful adjusting the stir. It's very easy to stir too aggressively, which can cause your reaction mixture to spill. This will take time to cool to room temperature, so be patient as you allow it to stir. While your beaker is stirring, we can get prepared to set up our vacuum filtration. You will need the following equipment: a sidearm flask, a hose, a Buchner funnel, a filter adapter, filter paper, a small size that fits the Buchner funnel. Make sure you have just one piece, sometimes they can stick together, and a watch glass. We're going to collect and dry our sample on this watch glass, so we need to know the mass of the watch glass and filter paper without the sample on it. Bring your watch glass and filter paper over to the scale and record the mass. In your lab notebook, be careful when labeling the masses you record. This here is the mass of your filter paper and watch glass. You will need this information for later. Back at your lab bench, we can finish setting up our vacuum filtration. You're going to connect one end of your hose to the vacuum line. You don't need to shove this on too far, just make sure you've got a secure fit and make sure that you're connecting to the vacuum line, not the gas line. You'll connect the other side of the hose to the arm of your filter flask. Make sure that the hose isn't going to cause the flask to be unstable. Just adjust it so that it seats comfortably. Put the filter adapter into the filter flask and then the Buchner funnel and filter paper. We're going to get the filter paper slightly wet so that it sits properly on the Buchner funnel and solid can't sneak underneath while we're filtering. Just add a tiny squirt of DI water to the Buchner funnel to fully wet the filter paper. Now we're ready for our vacuum filtration. Again, you can get all of this set up while your reaction mixture is cooling to room temperature. After 5 minutes, you can turn off your stir plate and remove your reaction from the stir plate. At this point, if your reaction is not yet cooled to room temperature, give it some more time. You want it to be as cool as possible before you filter. Once your reaction has cooled to room temperature, you're ready to filter your solution. Turn on the vacuum line and then slowly decant your solution into the filter. As before, use a stirring rod to guide your pouring. As you're pouring, be careful not to pour the stir bar out. Try and leave that and the solid behind in your beaker. Once you've got all of the solution out, you can put your finger in front of the mouth of the beaker and carefully collect your stir bar from the beaker. If there's any residual solid on the stir bar, you want to rinse it with a little bit of DI water to get the solid onto the filter paper. Now in your beaker, you should just have your solid. Use a small amount of DI water to thoroughly rinse your beaker and to transfer all of the solid onto the filter paper. It doesn't matter how much water you use here because we're only interested in the solid collecting on the filter paper. Once you're satisfied that you've rinsed all of your solid onto the filter paper, leave the vacuum on for an additional 5 minutes to dry your filter paper. After 5 minutes have passed, you can turn off the vacuum line and detach the hose from the sidearm of your flask to break the vacuum holding on your Buchner funnel. Once you've broken the vacuum, you can remove your Buchner funnel from the top of the flask. Now we need to transfer the filter paper containing our product to a watch glass. Do this using a spatula. Carefully lift up one edge of the filter paper and gently transfer it to the watch glass. Be careful not to leave any solid behind or spill any onto the table. Using a wax pencil, write your initials somewhere on your watch glass. You want to be able to find it after you put it in the oven. Place your watch glass containing your filter paper and product in the oven. Pay attention to where you put it so that you're able to find it later. Let this sample dry in the oven for about 10 minutes. After 10 minutes have passed, use an insulated glove to carefully remove your watch glass and sample from the oven. Make sure that you're grabbing yours and not mistaking yours for one of your classmates. Place your watch glass on the countertop and allow it to cool. Once your watch glass is cooled, you can record the mass of your watch glass, filter paper, and sample. Make sure that when you record this mass, you're labeling it very clearly. This is the mass of your sample, watch glass, and filter paper. Make sure to note which substance is present on this filter paper. After completing the other steps, your beaker containing your solid and stir bar should be dry. Once it's dry, you can turn off the stir and turn off the heat. Using an insulated glove, remove your beaker from the stir plate and place it on the counter to cool to room temperature. Once your beaker has cooled and you can comfortably touch it with your hands, you'll weigh the mass of your beaker. Remember to record exactly what you're weighing. This is your solid, beaker, and stir bar. You can record the identity of the solid in your lab notebook. Upon completing this experiment, you will have separated the 3 components of your solid mixture. Each component will be in one of these locations. Make sure that you understand which solid will be located in each piece of glassware. You'll notice throughout the experiment that we've generated quite a lot of glassware. It's important to thoroughly clean up your station before leaving lab and to properly dispose of all of your chemical waste. Liquid waste should be carefully poured into a liquid waste container using a funnel. Be careful not to spill as you're transferring your waste into the waste container. Once you're done, remove the funnel and recap the waste. Solid waste, such as your filter paper containing product, should be transferred into a solid waste container. You can put the entire filter paper into this waste container. Any other solid waste should also be transferred into the solid waste container. Again, place the cap on the waste container before you leave the hood. Lastly, make sure you thoroughly wash all of your glassware. You can use tap water to rinse all of the glassware we used in this experiment. After you've rinsed it thoroughly, use a paper towel to lightly dry it off. It doesn't need to be fully dry, just not dripping wet. Then you can return your glassware to the drawer where you found it. You shouldn't put any glassware on the drying rack, but instead return it back to where you found it. At this point, you are completed with the experiment.